Good morning, guys. So now, as you all know, that my name is William Waliu, so popularly called Dr. Nefron. So, today, I'll be giving you guys the formulas that you actually need for your to know for your Utme under the electrolysis. So what are the formulas that you need under the electrolysis? That is, there's no how they ask questions under the electrolysis, and you know this formula and you'll not be able to also get your answers. So because I've checked it from 1978, from 1978 to 2024 or 2025, I can see that JAM usually ask questions on the electrolysis. They usually ask questions on electrolysis, and the part that's giving people tough time is the calculation aspect of the electrolysis. Now, so this morning I'll be demystify the area of calculation under the electrolysis. So now let's continue. Let's move on. Now, let's continue. Formula to know under electrolysis. So what are the formula to know under the electrolysis? You see, do not forget that electrolysis is actually a non-spontaneous reactions. So when I said non-spontaneous reactions, there are some reactions that actually occur. They are forced to occur. We force them before they can occur. A good example of non-spontaneous is electrolysis. Why? Because we actually force the reaction to occur by passing the electric current straight. But there are some reactions that just occur on their own. They occur on their own. Examples of spontaneous reaction is radioactivities. So that's why when you are defining radioactivity, radioactivity can be defined as the spontaneous emission of radiations. That was the spontaneous emission of radiations. But when you are talking about something not spontaneous, so not spontaneous in the sense that they actually force them to happen. So they force them to occur. So either you pass the electric current through them, or you actually force them to occur. And for the spontaneity of the reactions, what are the conditions that have to occur is delta G must be negative for the spontaneity of the reactions. Why for the not spontaneity of the reactions, what are the conditions that have to occur is that delta G must be positive. And if delta T is positive, or it means delta H is also positive. But we are not into that. So I just wanted to know that what are the formulas that we have to know under the electrolysis. Now on the first one is the first formula to know under the electrolysis is equal to M equal to ZIT. And where do we derive this formula from? Now this formula will actually derive from the Faraday's first law of electrolysis. Now the Faraday's first law of electrolysis states that the mass of the elements deposited or discharged during the electrolysis is directly proportional to the quantity of electricity that passed through them. That is, the mass of the element is that deposited is directly proportional to the quantity of electricity that passed through them. Right? Now, don't forget that anytime you are removing sign of proportionality, we usually introduce a constant, right? But this time around, the constant we are introducing is constant Z. Now, if I remove this sign now, I'm going to have M equal to ZQ. But don't forget that the quantity of electricity is equal to current multiplied by time. Is that okay? So our Q is equal to what? Q is equal to current multiplied by time. Do you get it now? So, and if current is equal to, if quantity of electricity is equal to IT, that means I can go back to this to this expression, and we have what? We have M equal to Z. Instead of putting Q, what we put is what? What? IT. Now the first word, the first formula to know under what? Under this electrolysis what is the M equal to ZIT. I hope you are getting that. So that's the first word, the first formula to know under it. Now the second one is what? The second formula to know is what is, and before we actually move, before we actually continue, now what is that Z? What is that Z? Now what's the Z? This is called electrochemical equivalent. It is called electrochemical equivalent. Now, but do you know that this electrochemical equivalent also has a formula, but they will not tell you. Do you get it now? I don't know, maybe you have actually read it before, but it is very, very rare to find these formulas in your textbook. Now, the electrochemical equivalent Z is equal to, now, the relative molecular mass divided by charge of elements multiplied by Faraday constant. You can see that I actually said this formula is very, very rare. Do you get it now? So some of you might know it, while some might not actually know the formula. So the formula is equal to what? This electrochemical equivalent Z is equal to what? It's equal to the relative molecular mass divided by the charge of the element. That is the charge possessed by the element. So if you are talking about aluminium now, so the charge possessed by aluminium is what? Is +3. If you are talking about sodium, is what? Is +1. Calcium is +2. Oxygen, if I ask you what's for oxygen, you tell me -2. No, because there are some reactions. For example, now anodic half equation for oxygen, we have what? We have 4OH minus to give what? To give 2H2O, right? Plus oxygen gas plus 4E minus. That is 4 electron is what is actually required to actually deposit oxygen. Definitely the charge of oxygen here will be 4. Do you get it now? So this charge means what? The charge carried by the elements. Sodium is +1, calcium is +2, aluminum is what? Is +3. Do you get it now? Zinc